Bueno, buenas tardes a los que estáis ahí al otro lado de la pantalla.
Good
Agradeceros que hayáis
afternoon.
dado un año más
For
una
those who have connected remotely, I would like to thank the organisers for giving me the opportunity to talk about one of our projects. It's a great pleasure. In this case, I'm going to talk about Casa del Peregrino in Zegama on the Camino de Santiago, and it's part of research that we've been carrying out for some time about how we can develop sustainable architecture using solid wood constructions and structures through different repeated experiences, improvements evidently, because as we move forward, you learn and improve. We tried to build a series of buildings with energy performance levels and minimum environmental impact and high sensorial and material comfort based on interior atmospheres in which wood is the clear protagonist, as you can see in these examples. This research has been carried out in 4 buildings, the first being built in 2016, both own projects and also collaborations with other colleagues, architects. And more projects are undertaken, which entail greater complexity and of a larger scale. Using solid wood, the majority of these have been certified, in fact all of them, and some of these are in the tender or construction phase. In this case, I'm going to talk to you about the Pilgrims Hostel in Zegama, in a town in Guipúzcoa. The Basque Country has 2 ways of St. James or caminos, one via the coast and another inland, which links Irún with Vitoria-Gasteiz. And halfway along the road is Zegama, on the hillside of Expori, which is one of the emblematic peaks in the district, Al Goeri, a mountain area, but at the same time very close to Zegama. You reach this area through the San Adrian tunnel, as you can see there in the photograph, and there you can see the mountain range to the south of Zegama. Zegama's location was one of the first concerns we had to deal with. Its very specific climatological conditions. It's relatively close to the coast. The height is approximately 300 meters above sea level. That's the altitude. So it's a very mountainous landscape with a mountain climate. So we had to study the climatological conditions when undertaking this project. We compared real weather databases for Zegama with different climate profiles that are indicated in the PHPP and other climate profiles downloaded from general databases. And this prompted us to determine that the climate profile in Zegama was almost the same as in Vitoria. Together with Burgos, you may know that these 2 areas have some of the most severe temperatures or climate conditions in the Iberian Peninsula, both in terms of temperatures and radiation levels. In terms of conditioning factors at the outset of the project, the local town council, through work carried out with the municipal architect, the town council wanted the building to comply with passive house requirements to fulfill the town council's commitment to sustainability and also to provide guarantees in terms of the quality of municipal investments. And another conditioning factor was that it had to be made of wood. The plot was located next to the Wood Museum in the municipality, a museum that's fairly famous in the district. Therefore, to complement the Wood Museum, they decided they wanted to be made from local wood. It was located at the entrance to the natural park, which is marked there by the cursor. So towards the left of the building, that's the Esgori Natural Park, with many different paths, etc. So this would serve as a gateway to the park. it would mark the beginning of this route to the mountain range in the district. Well, the building program was very easy to understand. It was for a pilgrims hostel, and what they wanted to do was to construct a hostel for a maximum of 12 pilgrims with relatively simple volume, and which had to be relatively economical as well. The configuration of the building would revolve around this central space, which, as you can see there in the elevations, with 2 sleeping rooms or bedrooms, with let's say 6 bunk beds in each room, and on the right would be the area with the toilets and also canteen and another small room. All of this within a single envelope. In order to fulfill all of the thermal envelope needs, continuity, etc. As I mentioned before, the building was made entirely from wood, both the structure, CGT, with local wood from Basque Country forests. Both the structure and the envelope were made from wood, and the insulation, and also the cladding on the exterior and the interior. This volumetric construction, made entirely from wood, was supported on this foundation slab, insulated as always from the exterior, providing continuity to the envelope, and as I'll explain later on, this was an active insulation slab. As you can see in the photograph on the top right, we also introduced in the foundations the water piping in order to be able to activate that slab from an energy standpoint. There's some photographs of the assembly work. CDT, 120 millimeters, 3 layers. And we always use the same approach in our buildings. The roof is not done using solid wood, but rather using light wood panels, wood board, greater control of vapor diffusion is something that's achieved because we believe that that's probably where most problems exist, and also better use of the enclosure section in the thickness quantity or insulation capacity ratio. These were industrial panels, 12 meters and 12.5 meters long, 3 panels that you can see on the right at the bottom, which were placed on the roof of the building. Well, there you can see the photographs, and whenever working with CDT, in this case it was 3 layers, but we felt that the envelope needs were fulfilled here with that structural layer. In this case, the idea was to work on the joints between the different panels, as you can see here in the photographs, and with the different air tightness elements on the roofing, and combining this strategy of always trying to provide a correct approach on the interior and the exterior. There was no clear strategy, in fact. We have to adapt to the construction needs of each point in the building. So once the structure had been completed and the continuity of the air tightness had been achieved, then we would work on the insulation envelope using these vertical elements. These were then filled with wood fiber insulation and these impermeable and practical panels or sheeting on facades and also on the roofs. At the end, after the structural and hermetic line had been completed, then we could work on the insulation to protect the building against exterior atmospheric agents, and then we could work on the exterior and interior cladding. But we would always ensure the continuity of the envelope, as you can see in the diagrams, formed by structure and enclosures, providing continuity to the entire building envelope. In this case, the only points that would interrupt that continuity would be the downwater rain pipes, again, which were also embedded in this type of insulation, but you can see in the thermal insulation calculation, then the values are indicated there on the slide. At the end of the day, this is a thermal bridge with low impact, and which is perfectly acceptable. More details about the way in which the project was resolved. In this case, thermal bridges. There's the meeting between the facade and the roof with the overlapping section, and also the sections where we could integrate the gutter and ensure that it would be concealed or hidden. Sometimes there can be geographically negative thermal bridges, but these are not taken into account in the energy balance. In terms of the meeting point with the terrain, 0.07, 0.05 is another important value there, where it passes through the flooring. And as you can see, the values were very, very low, or even negative, and it wasn't even necessary to take them into account. So as part of this research and learning process in these projects, we've managed to optimize different solutions to achieve this truly thermal bridge-free building envelope with both structural and construction solutions that are more efficient and also much more aesthetic. In the case of the carpentry, well, this photograph of the window, we had over-insulation without frames. The value was acceptable, 0.032. But since we had to frame these windows with these special sheeting drawers or casing to provide shade, we also decided to over-insulate, take advantage of that option, and at the end, the thermal bridges presented very acceptable values. And well, here you have a photograph of the exterior. It also gives you an example of how this can be integrated very naturally in the environment, in the Ezcorri Natural Park, with the facade, no treatment. And the wood will clearly begin to adapt and age, and thus adapt to the natural environment. Around the building, the facade allows us to resolve the entire facade and also conceal exterior installations. And the idea, or the purpose here, was try to ensure that the building would actually seem invisible or disappear to the naked eye and merge with a natural environment. On the interior, well, as I said before, we sought a sensorial and comfortable atmosphere, in material terms, of course, using different products made from wood. Wood being the protagonist in these spaces. And you have to remember that pilgrims travel from France to Santiago de Compostela, so the idea here is that they can enjoy this experience, not just in terms of comfort and also in energy terms, but also have a comfortable experience with the materials, a different experience on their pilgrimage to Santiago de Compostela, which is perhaps a little bit different to other hostels they may stay at along the way. The central space with the entry of sunlight, and wood as a protagonist, but also wood as a protagonist in the kitchen, in the canteen, and also in the bedroom areas, where you can see that wood's been used right as much as possible for the shelves and the cupboards, so that the pilgrims can leave their rucksacks, their shoes, etc. One lesson that was learned from previous projects in buildings, and which gave rise to certain concern, the difference in inertia between the foundations. In this case, it was a solid slab, 30 centimeters insulated on the exterior below and paved directly on top, and also the lack of inertia of the light enclosures made from wood on the facades and also the roofing. That difference in phases between solid concrete and light wood, that difference, the decoupling in terms of the demands of both treatments and the poor performance in the winter, of the concrete slab, which cannot adapt to temperature changes. Well, that was one of the concerns and one of the elements that has to be resolved. Although that may favor us in the summer, in the winter it penalizes us in comfort terms. Another important shortcoming or handicap was the question of shade. The town council didn't want to have any type of awnings on the exterior, any elements that could be manipulated or used by users. So this prompted us to use different types of solutions to protect against exterior sunlight on the southeast wing. And as you can see, the solutions adopted in the openings to have these recessed sections on the east and west. We knew that this was going to give rise to problems. Evidently, since there was no correct or adequate protection against sunlight on the exterior, the building would suffer from overheating. That was inevitable. But this combination of decoupling in terms of the different treatments, this overheating that I mentioned, and also the intermittent use of this building, which I'll explain in detail later on, because there would be times in which it would be occupied by 12 pilgrims, but in other times of the year there would be nobody or just one or two. So the facility would have to provide a rapid response, even within the same week, when maybe nobody would be staying at the hostel, and other times during the weekend when it would be full, for example. So this required a rapid response. As a result, we decided to promote activating the concrete slab in energy terms so that we could maintain that value constant, the necessary constant atmosphere on the interior of the building, and on the other hand, air conditioning system using split system, which would provide necessary cooling in the summer and also heat required in the winter. This could be done on a split basis and provide a flexible solution. And finally, the question of use. As I mentioned before, maximum capacity of 12 pilgrims was provided, but in a hostel on the Way of St. James, in a small town, in a remote part, which may be a less transited part of the Way of St. James or the Camino, well, occupancy would vary enormously even within the same week and from day to day. One day there may be 3, 4 pilgrims, 8, or even none. So the municipality had no way of knowing beforehand how many people would stay at the hostel to enable us to plan the air conditioning and heating requirements and also the use of energy. So we decided to plan different usage scenarios as shown here on the slide. The average occupancy would be 6. There you can see the values provided in the PHPP with a maximum occupancy of 12 and a minimum occupancy of 1. But at the end of the day, we decided to study these two potential scenarios, maximum and minimum occupancy and average occupancy, dimensioning the ventilation installations and also the air conditioning and heating installations to ensure that the building would always comply with certification ranges, and so that at all time the building's installations could satisfy cooling and heating demands according to the different occupancy levels and the intensity of use. It was a very interesting study. We learned a lot from previous projects, and in this case I think that we resolved the issues in an optimum fashion. Finally, together with the certifiers and the Institute, we decided to certify the building with the average occupancy value of 6 users, and the slide shows the certification values that we obtained in April this year. Well, in April this year, as you know, we were all locked down. The COVID-19 pandemic had hit hard, and so the building couldn't be used in full. But we did take advantage of that period to carry out monitoring studies. The building was monitored in the month of July, and surprising readings were obtained, notably thermal variations at the beginning in July daily temperatures of 25 to 35 degrees and nighttime temperatures below 15 degrees on most days. So interior temperature stability was clearly reflected with respect to the variation in exterior temperature. But one surprise initially was that on the ground floor and the first floor, temperatures were high, 25 degrees, maybe a bit below, a bit above. But this reflects the reality indicated in the PHPP, which indicated that when the building's not occupied and not being used, with ventilation at minimum levels, as at present, or without cooling and heating, well, in the summer months, there would also be a high level of overheating. And the real results confirmed what the PHPP indicated, and which will be resolved through adequate use of the installations. And there's not much more for me to add. As always, I would like to thank all of those involved, the architects, the surveyors, the developer, the engineers, the certifier. It's been a collaborative project. That's the most important thing I'd like to highlight, because it's a good way of ensuring projects of this type are successful. And there's not much more for me to add. Thank you.